Paper of the day is Latch-free synchronization in database systems. Is it a silver bullet or fool's gold? It's a 2017 paper. This paper analyzes the various factors that influence the performance and scalability of latch-free and latch-based algorithms and perform a micro-benchmark evaluation of latch-free and latch-based synchronization algorithms. Their findings indicate that the argument for latch-free algorithms' superior scalability is far more nuanced than the current state-of-the-art multi-core database architecture suggests. This paper highlights the often underappreciated fact that latch-free algorithms generally require idiosyncratic memory management mechanisms. Latch-free memory management mechanisms add complexity and overhead relative to latch-based algorithms. These mechanisms are often ignored or omitted in published descriptions of latch-free algorithms and have consequently been a source of bugs in implementations of these algorithms. The paper performs a set of micro benchmarks that makes an apples-to-apples comparison between a latch-free algorithm and three classes of latch-based algorithms. They find that while the latch-free algorithm does outperform simple busy waiting latches, the results in comparison to more sophisticated back-off latches are mixed. Furthermore, they also find that latch-free algorithm is never able to outperform a scalable queuing latch. Now let's look at the experimental evaluations. This paper compares the performance of a latch-free synchronization algorithm to three classes of latching algorithms: a busy waiting spin lock, that is Tata spin locks; back-off latches which put threads to sleep under contention, aka pthread mutexes; and scalable latches which avoid spinning on a global memory location, that is MCS latches. They evaluate each synchronization primitive on a benchmarking framework which precisely controls amount of parallel and serial work each thread must perform. Threads execute in two phases, a serial phase and a parallel phase. Both serial and parallel phases consist of a fixed number of no-op instructions. The duration of the serial and parallel phases is varied by changing the number of no-op instructions to execute. Coming to the contributions of the paper. Latch-free algorithms usually, but not always, outperform their latch-based counterparts when the number of OS contexts exceed the number of cores in the system. However, as modern database systems, especially main memory database systems, move to a process model where there is a one-to-one mapping between OS contexts and processing codes, the progress guarantees of latch-free algorithms are marginalized. Instead, they are subject to the same type of synchronization overheads as latch-based algorithms. Their generic latch-free algorithms was never able to outperform a scalable queue-based latching algorithm in such an environment. Furthermore, latch-free algorithms often necessitate idiosyncratic memory management mechanisms and other complexities not present in latch-based systems. Now let's give this paper a PS score. Overall, it's an engaging read, so it gets 9 out of 10 on readability. With 12 pages long, it scores 9 out of 10 on length. Reproducibility will be challenging and interesting, so it gets 8 out of 10. Industry value and learning meter is decent, so it gets 8 out of 10 and 9 out of 10 respectively. Overall, the PS score is 9 out of 10.